Hey everyone! Today we're going to move into the next topic in scientific notation. In particular, now we're going to start adding and subtracting these numbers when they're in scientific notation. So we're going to have things like this, 5 times 10 to the third plus 2 times 10 to the third, and we're going to do some subtracting and a little more complicated ones. The IXL, I just want to point out, it's kind of a funny numbering. This is a new one, so they don't have the normal numbering. It's in the W section, but it has a special number. You might have to look it up, VJL. All right, great. Well, let's go ahead and here we go. Let's get started. For our first problem, then, we'll be looking at this one, 5 times 10 to the third plus 2 times 10 to the third. This particular problem is going to be convenient because it turns out both of these exponents are the same. We're going to talk later about what we do if they're not. But in this case, they're the same. So what we want to do is, it's actually a lot easier to do the work if we set it up vertically, which means you're going to have to get some scratch paper. Just really do not try to do these in your head. They're going to get way too hard. So it will help you immensely to have paper when you do this. So I've set it up like this. I am going to add them. Kind of like just, when we add numbers, digits, decimals, things like that. Now what's going to happen, the 5 and the 2 add up. That kind of makes sense. But what is a little different, and we have to get used to here, this is just 10 to the third. Because essentially what this is look, this is 5 times 10 to the third. That's saying 5,000. 2 times 10 to the third is saying 2,000. Now, 5,000 plus 2,000 is 7,000, right? In other words, look, the 1,000 didn't change, did it? Same thing here is 10 to the third. It didn't change. Again, we got 5. Think of it as almost like apples or oranges or something, right? I've got 5 10 to the thirds. I have 2 10 to the thirds, so altogether I have 7 10 to the thirds. Now, I'm not going to write something that's wrong, but I'm going to show it to you because a lot of people do it, and I just want to explicitly point out, don't do what I'm about going to do here. Okay? There are people, and sometimes I do it too if I'm not careful, right? You think, oh, 5 plus 2 is 7, 3 plus 3 is 6. Okay, 7 times 10 to the 6th, right off the bat. Don't even get too comfortable with that. That is wrong right off the bat, okay? That's not right. Because that would be like saying 7 million, right? That would be like saying 7 million. Well, you don't say 7 million, right? 5,000 plus 2,000 is not 7 million, is it, right? It's 7,000. Same thing goes here, right? So do not add the exponents. Do not add the exponents. Hey, did I mention don't add the exponents? Okay, let's move on to another one. All right, so we've got another one here. Same kind of thing. Okay, again, we do have the same exponents. We have the same exponents. That's going to make our life easier. We'll talk in a minute what to do if they're not. But since they're the same, just like we did the last one, let's set that up. So I've got 7.3 times 10 to the 6th. Now, this is what's critical. There's an implied decimal point here. Okay? You have to line that up with the other one. So make sure that it's right there, right? This is like saying 5.0 if you like. Again, times 10 to the 6th. Right, times 10 to the 6th. We have the same exponents, So everything's great. We add it up, and right, 7.3 plus 5, right? That becomes 12.3 times 10 to the 6th, right? Again, it's like I said, 7.3 million plus 5 million equals 12.3 million, right? It's all the same stuff, right? This tells me it's a million, this tells me it's a million, this tells me it's a million, okay? So now, that looks pretty good, except that this is not actually scientific notation anymore, because the coefficient in front cannot be bigger than 10. Well, it can't even be 10. It must be less than 10. Or another way of thinking of it, you cannot have this decimal point this far over. We really want this decimal point to be right there, right? So I'd like to be able to move that over. Now, if I do that, think about what just happened. I made this get bigger, right? It was bigger, pardon me. I made this get smaller, right? I just made, it was 12.3, I made it smaller. Well, if that gets smaller, then this has to get bigger, right? They have to go in opposite directions. It sort of counterbalances. So if 12.3 went to 1.23, then this 6 has to become a 7. And then our answer is just 1.23 times 10 to the 7th. Okay, so again, this is now in scientific notation. All right, this is a good time to kind of think about what we've been doing here. You know, there are some particular rules or procedures that you want to follow, and here they are. So when we are solving problems like this, here's my strong recommendation for you. We want to work vertically, which means you got to use paper, right? So work vertically, use paper. Now the other thing we got to do, right, if we work vertically, use paper, is we've got to make sure that they are the same exponent, right? Now we're going to talk in a minute what happens if they aren't, but in this case they were, so we're okay. You're going to add or later subtract the coefficients, but not the exponents, right? Notice I added 7.3 and 5, but I left the exponents the same. Finally, we might need to fix the format like we did here. See where we fixed the format, okay? So not a bad idea to stop, pause, write these down. These are really important steps when we're adding in scientific notation. Okay, so let's move to our next problem. So in the next problem, I've got 6.1 times 10 to the 8th, and now look what happened here. I've got different exponents. This is an 8, this is a 9, okay? We're going to have to do something here. We're going to have to get them in the same format, right? It's the old comparing apples and oranges. You got to have the same stuff, and we don't have the same stuff yet, but we'll fix it. Don't worry. Okay, so let me just get it started, and then we'll fix things. So I've got 6.1 times 10 to the 8th plus, now I'm going to go ahead and line this up, but we're going to actually move it in a second anyway, times 10 to the 9th. Okay, again, the problem is that's an 8 and that's a 9. That's not what I want. So it turns out what I can do is, again, this is like 4.0. If I could turn this 9 into an 8, so let's just say that that's what we're going to try and do. I want to turn this 9 into an 8. Now we've got the same exponent, but I can't just do that on my own, right? So again, it got smaller, so the coefficient needs to get bigger, right? They go in opposite directions. So again, the power of 10 got smaller, so this needs to get bigger, which means I have to move the decimal to the right. I'm going to turn this 4.0 into a 40. Okay, now let's rewrite this. It's getting messy. Our decimal points don't line up anymore. So we're gonna rewrite this as 6.1. Now, we still have this one, okay. But this is now 40, and we'll just make it, notice the decimal points line up now. So that's good. Times 10 to the 8th, okay, right? So again, I can now add those up. Oops, I didn't want that to be that. Actually, wanted those to be arrows, right? So this became that, and then we're going to add them up. So I'm going to add them up, and again, I add the coefficients, but not the exponents. So when I add that, I get 46.1 times 10 to the 8th, right? Again, we got common coefficients, or the coefficients add, but we have common exponents, so everything's good. Well, almost good, because this isn't scientific notation anymore, is it, right? This number is too big. I want the decimal point just on the other side of this 4. So I'm going to have to move him. So I'm going to move him over there, okay? But let's think, 46 to 4, that means it got smaller. If the coefficient's getting smaller, the exponent has to get bigger, right? You have to counterbalance. They have to do the opposite. Either, like in this case, this one got bigger and that one got smaller. Here, smaller and bigger. But they're always going to go in opposite directions to basically counteract each other. So this then turns into a 9. And our final answer then is 4.61 times 10 to the 9th. All right, cool. Again, let's just review our steps here, right? We're going to work vertically, and that means we're using paper, right? So working vertically. We made them the same exponent. Super important. I add or subtract the coefficient, not the exponent, and then I fix the format. Okay, great. Last problem, we're now going to take it up a notch and we're going to subtract, right? So notice this one's a little different. Up till now we've been adding. This one we're actually subtracting the values. Okay? So again, just like before, we're going to let's use our steps, okay? So first things first, I'm going to work vertically. So I got to rewrite these in a vertical fashion. I've got 5.6 times 10 to the 12th minus 4.9 times 10 to the 12th. Again, exponents are the same, so everything's great. And I just subtract 4.9 from 5.6. I made sure I had my decimals lined up. And this becomes 0.7 times 10 to the 12th, right? Now 0.7 times 10 to the 12th, again, it's the right number, but it's in the wrong format. I've got to fix my format, okay? So I'd really like this decimal point to be over here, wouldn't I? That's where I'd like him. But basically, I just made him get bigger. He was 0.7, now it's 7 in front. If he got bigger, the exponent has to get smaller so that overall it's the same value. So rather than 12, this is going to be an 11. And my final answer is 7 times 10 to the 11th. So there we go, guys. Make sure you copied this down. And next time, we're going to learn how to multiply with scientific notation. Talk to you then.